sure what it means as well, but an arc that measures between 0 degrees and 180 degrees. And you write a minor arc with 2 letters, and it'll become clear as we keep going, I promise. So it's sort of a curve, and then like, say, the letters A, B. So I'm going to show you in a picture. It's an arc that measures 0 to 180, and you write it with 2 letters. So up here, let's put the center C. We'll draw 2 radii like this. And this piece right here is the arc. It's arc AB. All right, so a minor arc. Guess what a major arc is?
A minor arc, but bigger.
An arc that measures.
180.
I mean, to be specific, we should say probably 180.1 or something, but we'll just say 180 to 360, and it'll be clearer when I do the next definition. And you write a major arc with 3 letters. So if you see an arc symbol and it's got 3 letters under it, it's a major arc. So let's say A, B, C. That means it's bigger than 180, that arc is. Yeah.
Are you going to do the thing today where you like multiply one of the radiuses by like
I'm listening.
you do it times pi and then you divide it by 180 and then you do that times the radius or the measure and then you can get it so you get the thingamajig and you find the length of the arc.
Yes, in a way, yes.
Are you doing that today or is it more complicated?
That's coming up. Okay, so here, on this drawing, right here, this is called a major arc right here because it's bigger. That's a major arc. So I would call that arc LMN. Okay? Then, in between here is a semicircle. It's an arc that measures how much, do you think? If it's a semicircle, 180. You also use 3 letters for a semicircle. Okay, what do you think would make congruent circles? What has to be equal in both of those? Yeah, but all circles are 360. What part of the circle has to be congruent with the other part, do you think? What? Right, or the half that is the what? Radius, right. Okay, 2 circles that have the same radius. Or diameter. Now, in order to have congruent arcs, you have to have 2 arcs on the same circle, and we'll look at all these, or 2 arcs on congruent circles. Okay, the arc length is just a portion of the circumference of the circle. Portion of the circumference of the circle. That's my phone, or is that your phone?
Oh,
See, I don't even look at it. I'm not like getting up and looking. I can ignore it. They know I'm working. Whoever it is that needs me knows I'm working. All right, so let's do this together. There are, no, don't do it together. Do it with your partner. Fill in the blank. I'm not going to tell you. Try it.
Yeah. I don't know. I don't know.
Would you guys get for number two? Number two.
Two's the hardest one, I think.
It's like the thing where it's like the
You learned it first semester. We'll talk about it.
I think circumference is for circles. But I'm in pen and I don't want to.
It's okay to cross it off if it's wrong.
I'm OCD about that. No.
for what?
Approximation pi is 3.1. I'm just going to wait.
Okay. How many degrees in a circle?
360.
360 degrees. An angle whose vertex is the center of a circle is called a... Wow, we should go talk to Mr. Miller.
He's me. No.
Don't remember. Starts with C.
Circumference.
Close.
Central.
Central. Central angle. It's called a central angle for number 2.
Yeah, I'll remember why not.
I remember it like now, but I don't know.
Did you see his
Okay.
I'm saying central.
Number 3. A what is a segment whose endpoints are the center of a circle? A radius. Number 4. The blank of a circle is the distance. It's the circumference. That's right. 3.14. KK?
Oh, why is
Okay. This is the thingamajig that Ethan was talking about. Okay? In a, now then, in a circle, the ratio of the length, we're going to,
I'll show it to you.
hold on. There's 2 things we're going to work with today.
Just make us one quick.
Shh. The angle measure, or excuse me, the arc measure. Measure is the angle measure. Arc length is this piece right here. They're 2 different things. And this is how you find the arc length, and we will use it on the other side, but just write it down. So the ratio of the arc length to the circumference equals the measure of the arc divided by 360. Now,